Picking a threshold value in case of a classification algorithm is often challenging. The receiver operator characteristic curve or the ROC curve helps us decide a good value of threshold for our model. So let us see in this video how do we decide a threshold by looking at the ROC curve. The ROC curve has on the y-axis the sensitivity or recall or the true positive rate. So this represents the proportion of actual ones that the model has identified, and on the x-axis of our ROC curve we have 1 minus specificity, which also means the false positive rate. So this represents an error parameter. It represents the proportion of zeros that we have predicted as 1. So this represents the false positive rate. So the zeros that we have predicted as ones. So this is the error. Now our ROC curve represents, this line represents the different values of threshold that we have into our model. So it starts from a threshold of 1 and slowly decreases all the way to a threshold of 0. So this curve is plotted for different values of threshold. So this starts at a threshold of 1. So when you take a threshold of 1, this means you do not predict any ones into your out of your observations. Since your threshold is 1, you are not predicting any ones in your data. Of course, when you don't predict any ones in your data, your sensitivity, which is the true positive rate, will be 0 because you are not predicting any ones in your data. So this will be 0. At the same time, the false positive rate or 1 minus specificity will also be 0 because you are not predicting any ones. So your predictions of ones will be 0 in this case because the threshold is 1. At the other extreme, you have a threshold of 0. So when you have a threshold of 0, you predict 1 for all the observations. So in this case, you will obviously catch all the actual ones into your data. Since you have predicted everybody as 1, you will catch the actual ones. So your sensitivity will be 100%. But the flip side is that for all the zeros as well, you will predict a 1. So your false positive rate will also be 100%. So this is the two sides of taking a threshold. Now what we generally take is somewhere in the middle. So there is always a trade-off between the sensitivity or the true positive rate and the false positive rate. So we try to minimize the error based on our business requirement. So let's take this point. So this point corresponds to a threshold of around 0.6. So if you select a threshold of 0.6, you will get a sensitivity of 50%. So this gives you a sensitivity of 50%, which means you are catching 50% of your ones correctly, or the model is identifying 50% of the ones correctly, and it will have a small error in this case. So the error is around 10%. So the model, on the other hand, it is able to identify 50% of the ones, but it is also misclassifying 10% of the zeros as ones. So this is the error that the model is making. Now if you go further ahead, let's take this particular point. So let's say this is a threshold of 0.40. So if you take a threshold of 0.40, your sensitivity would increase to around 90%. So this is 90%. So this means you're able to identify 90% of your ones correctly. But the flip side is that you have a false positive rate of around 50%. So 50% of the zeros are being classified as ones by your model. So depending on the business requirement, what do you value more? So if identifying ones at the cost of misclassifying a few zeros is your need of the business, then we go for a high value on this axis. So we will value the proportion on the y-axis more than the error on the x-axis. But if your business does not require you to go for a wrong classification, you will try to be as low as possible on the x-axis. So depending on your business requirement, you identify your threshold from a ROC curve. Now let us see how do we get the ROC curve in R. So we'll come back to the previous example that we discussed. So we will use the Boston dataset from the mass library. So remember, Boston dataset is actually a regression problem, but we converted it to a classification problem by creating a new variable called luxury house, which takes a value 1 if the price of the house is above the median of all houses, and which takes a value 0 if the price is less than the median price of all houses. So this is how the dataset looks like. Quick recap. So luxury house, if the price of the house is less than the median, which was found to be 21, then it's a luxury house. And if it is less than the median, it's not a luxury house. The proportion of ones and zeros in our data, it came out to be 50% of the data was a non-luxury house and 49% was a luxury house. So let us start with the logistic regression process. We have seen these in a previous video, so I will directly run over this. And I will predict on the same data set. I don't have a separate test data here. I'm predicting on the same data set. To get the probabilities out, I'm using the type is equal to response function in R. So if we don't use this, we will get the log of odds instead of probabilities. Okay, now let's start with the ROC part. So we will use the ROC package in R. So I have installed it already, so I'll directly load the package. And to get the ROC curve, we will use the prediction function. So prediction function, it takes the input, the predictions that you have made, the predictions in terms of probabilities that you have made. So I stored my predictions in the vector pred. So I will use the vector pred here. And then you pass the actual values of the dependent variable. So the actual values of my dependent variable are in the data frame Boston with the column name luxury and the core house. So this I'll store it in a variable called ROCR. Now we will use the performance function, and I will give the previously created variable ROCR, and I will give what I want on my y-axis and what do I want on my x-axis. So I want the true positive rate or sensitivity on my y-axis, and I want the false positive rate or 1 minus specificity on my x-axis. So let me run this, and then finally I will plot the ROC curve. So I will plot the variable perf which I created earlier, and I will give a few intervals here, intervals for the threshold. So here I have used the sequence function between 0 and 1 in increments of 0.1. So 0, 0.1, 0.2 and so on till 1. It will denote me a point giving the threshold. So let us see the ROC curve. So this is what we get as the ROC curve. So you can see we have a threshold of 1 here and a threshold of 0 here, and the threshold is gradually decreasing. So 0.9 is the threshold here. So now we will decide a threshold looking at this figure based on our business needs. If the business requires you to have a very high true positive rate and the business does not care about the false positives that you make, you will select a small value of threshold, maybe somewhere here. So 0.2 looks to be a good number. You will get almost 90% sensitivity or true positive rate, and at the same time your error will be around 50%. But since you do not care about the errors, your goal is to identify the ones correctly, you are okay with a threshold of 0.2. So this is typically the case in healthcare, where you are trying to identify a patient who has a rare disease. So you do not want to miss any patients, so you will go with a high rate of a high sensitivity, and even if it comes at the cost of a few false positives. But in other scenarios where you do care about the errors that you make, where you do care about the false positive rates, you would try to be low on the x-axis, and for that you will select a threshold somewhere maybe 0.8 or 0.7. So at this point, for example 0.7, you will get a sensitivity of around 67 or maybe 70%, and your false positive rate will be very less. It would be around maybe 5 to 8%. So this would be a good threshold to select if you want to limit your false positive rates. For this purpose, I will go with a threshold of 0.6. So I care about my sensitivity, but at the same time I don't want to increase my false positive rate. So zero point 0.6 threshold looks to be a good number in this case. I should get a sensitivity of around 80%, little below 80%, and my false positive rate should be around 10%. So 0 0.6 is the threshold I will select for this example. So I'll assign it to a variable t, and then I will use the if-else function in R to convert the probabilities to ones and zeros using the threshold t. So I'll use this function, and finally I will compute my confusion matrix using the table function in R. So this is the confusion matrix I get, and now you have the confusion matrix. We have seen this in a previous video. You can compute all the accuracy parameters, sensitivity, specificity, precision, and accuracy from this confusion matrix. So this video explains how do you decide a threshold from a ROC curve, and depending on your business requirements, how do you decide what threshold to select from a ROC curve.